Hello everyone, this is Kitish here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier from 2023. Question number 4 is on the topic of energy. A remote village in the UK uses a hydroelectric generator to provide electricity. In one day, 2,500,000 kilograms of water passes through the hydroelectric generator. The change in gravitational potential energy of the water is 367.5 megajoules. Now, this M stands for mega. And mega means 10 to the power 6. Right? Remember, let me write it here. 10 to the power 3 is kilo. 10 to the power 6 is mega. 10 to the power 9 is giga. The gravitational field strength is 9.8. Calculate the mean change in vertical height. Mean change in vertical height, which is h, of the water as it moves through the hydroelectric generator. Use the physics equation sheet. That would be gravitational potential energy, GPE, or if you look in the equation sheet, you will find it as E, P for potential energy equals mgh, the mass, gravitational field strength, and then the height. So let's rewrite the equation. E, P, potential energy is equal to the mass, gravity, and the height. So I'm going to leave this as 367.5. Instead of writing it as megajoules, I'm just simply going to write 10 to the power 6 equals, I don't have to convert it just to avoid making mistakes. And the mass is 2,500,000, same as the way they have given it above, which is over here, multiplied by 9.8 times the height. Rearranging the equation, height equals 367. Now, if I was to actually extend this from standard form into just normal numbers, it will be 500 and 3 zeros. That's 367,500,000 divided by 2,500,000 multiplied by 9.8, and that would give me an answer of 15 meters. 15 meters. The generator transfers 3 kilowatts. So again, remember, 3 kilowatts is 10 to the power 3, or you can convert it to 3 times 10 to the power 3, which is 3,000 watts, which is the power. The time taken for the generator to transfer 2.16 times 10 to the power 7 joules of energy. Calculate the time taken. So power equals energy divided by the time, or if you rearrange it, let's substitute the values first. The power is 3,000 equals 2.16 times 10 to the power 7 divided by the time. So the time equals 2.16 times 10 to the power 7 divided by 3000, and that gives me 7,200 seconds. 7,200 seconds. Figure 5 shows how the power output of the generator varied during 1 year. As you can see on the graph here, the y-axis, the power output of generator in kilowatts goes from 0 to 5, and in the x-axis you've got the months starting from January to December. So the power output from January goes down, and the lowest is in the month of July, and then increases back up again in December. Again, here we are talking about a hydroelectric generator, which depends on the amount of water. So why would the power generated during the months of the summer, which is usually between May, June, July, August, why is that the lowest? A solar power system is installed in the remote village in addition to the hydroelectric generator. Explain why this improves the reliability of the electricity supply to the village. Now, installing a solar power system means that they can produce electricity during the summer months. Let's say between these 2 points, right? Between May and mid-August. The power generated falls below 1.5 kilowatts. During those months, if you needed more electricity, if you installed a solar power, that would mean you can actually generate more electricity, because those are the months where you're going to have a lot of sunlight. Explain why it improves the reliability of the electricity supply to the village. Use the information. So we need to make reference to the graph as part of the answer. Right. In the summer, the power output from the hydroelectric generator is lower, but the solar power output would be greater. So less variation in the total power output, which improves the reliability of the supply. That brings us to the end of this question. I will see you in the next question.